Welcome to a quick tutorial on R programming. R is a powerful open source programming language that's particularly popular in data science, statistics, and data visualization. Whether you're analyzing data, building models, or creating reports, R has got you covered. Before we dive into coding, we need to install R and RStudio. R is the engine that runs your code, and RStudio is the user-friendly interface that makes writing and running R scripts a breeze. To install R, visit CRAN website and download the version that matches your operating system. Next, head over to the RStudio website and download the latest version of RStudio. Install both and you're ready to start coding. What are packages? In R, packages are a collection of functions and datasets that extend the basic functionality of R. Think of them as add-ons that give you access to specialized tools for different tasks. To install a package, you only need to do it once. You can either use the command install packages, package name, or go through the RStudio interface under tools and install packages. For example, let's install the R Data.table package, which is an enhanced version of data frames in R and is particularly efficient for handling large datasets. If we get a prompt to restart R, we usually go with yes and allow the system to restart while installing the package. After installation, you need to load the package in every new R session using the library function. And that's it. You are ready to use all functions and features within the package. Now let's look at a common task. Reading a CSV file into R. We'll use the fread function from Data.table package, which is faster than the base R read CSV function. Here, fread reads the CSV file and loads it into a data table called data. It's that simple. Let us also look at an alternative way to import data from a CSV file. We go to this tab, click on the box select function, and from the drop down we select read R because we are trying to import a file from text. Select this. We locate the file on the browser. Once the file is located, we are allowed to choose what each of the columns type should represent. In this case, company code represents a character since it will be used for merging or comparing data. Same goes for company name. The third column contains dates and needs to be formatted accordingly. Our date here is in the form of %D, M and Y. And our returns are in form double, which means it's a number. So we can rename this to data and we are done. We click on import to import the file for us, and this is the final file. Let's look at the data. It contains company code, company name, dates and return. The data table offers powerful functions to manipulate your data. Let's explore a few examples. First, lead and lag. These functions help you shift columns up or down, which is essential when analyzing time series data or preparing features for regression models. In this example, the lead value shifts the column forward, the lag value shifts it backward. This is particularly useful when you're working with time-dependent data and need to calculate the effect of past values on current outcomes, a common scenario in time series analysis. Let's see how these work. We've run the code for lead and lag values. Let's look at the second value, which is 0.88. We see that for lead value it comes in the row before that, and for lag value it comes in the row after that. Hence, lead and lag are correctly created. We can also use data table to filter data. For example, data 2 is creating a subset of data where BSC returns are positive or greater than 0. Data 2 only has 4,30,000 rows as compared to 4,38,000 rows. Hence, 8,500 odd rows which were containing negative values for BSC returns have been removed from this. Moving back, let's understand grouping with by. Grouping data by a specific column is essential for summarizing data within groups, which is a crucial step in data pre-processing for regression models. In this example, we calculate the mean value for each group defined by the group column. Grouping is particularly useful in regression analysis when you want to control for categorical variables or calculate summary statistics like means or medians within each group before including them in a model. Using the code on line 21, we try to find the mean value of BSC returns for each company. Let's see the value that is contained in data 3. So we get one value for each of the companies that were listed. Next, let's read data for NSC. Now we have NSC returns. We use the merge functionality of Data.table library to merge our original data which contained BSC returns and NSC data such that both NSC and BSC returns are contained in the same file. Please note that we have used three columns, that is company code, company name and date, to merge the data so that Appropriate rows are matched against each other from the datasets and the combined data is comprehensive. Let's view this. As we can see, we have BSc returns and NSc returns both in the same column. Wherever the written data is not available, we see NA values. In this instance, we had used all equals to T, which means that all the values from both the datasets should be included in the final output. Let's try removing this all T and see what the output is. In this case, only the rows where data is contained in both first dataset and second dataset will be combined to give the final output data. That's a quick review of how to get started with R and Data.table. With these tools, you can handle, analyze and visualize your data like a pro. Don't forget to explore more packages and functions as you dive deeper into R programming. With that, we'll end today's episode. Please do provide us feedback in the comments. If there is any topic you would like us to cover, please mention it in the comments section. Thank you, bye bye, and all the best.